Hi, sir. This is regarding the introduction to data science assignment 2. Okay. And we are trying to solve the use case which is related to intrusion detection system. And we have downloaded the data from this specific URL. Okay. Let me copy paste. It's loading. Okay. This specific like URL. So the files whichever we have used as part of our model development is KDD cup names, as well as KDD cup data 10%, and as well as training attack types. So these are the files we have downloaded and kept in the specific folder. Like this is the folder we have used to keep all the data related to model building. Okay, here KDD cup data, KDD cup 10%, KDD cup names, and we will be discussing in further, like we will be reading these data files in the IPython notebook. Okay. So here we are trying to download all the necessary libraries in the data acquisition. So as part of the data acquisition, there are the 3 steps involved here. One is like reading the names. So this names is nothing but this is like this use case. It's like a challenging one. Why? Because we are not reading the data frame as it is, like data as well as its associated names. So initially we are reading all the names, that is like column names. So these are like only independent features. Okay. Next, like we'll be reading the dependent feature here. Okay. So dependent feature, it's a related as intrusion detection system. So it is having total like this many types of intrusion detection types. This is the dependent feature. Next, like we'll be reading the raw data. So this raw data will be not associated with any target here. Like means not target. It's not associated with any column names here. You can say that only data here. Okay, so now it's a challenging to read independent features, dependent features, and make it as a readable data frame. So these are the steps we have used to make it as a readable. Okay, first one is like we'll be reading all the names, independent column names. Then we'll be trying to clean it up because independent feature it's associated with like data type also, but it will be not useful. We pass it as it is at straight away to read the data frame. So that's why we have to clean this data types, continuous, symbolic, continuous, everything we have to remove. So to do that, we have one of the user defined method here, clean independent columns. So by using that, we can clean all the like unwanted data. Okay. So if you type here, then we'll be getting all the clean columns. So total will be having total 41 of independent columns. Next, like we'll be reading the target. Target also it's not a straightforward. It's associated with because here basically 5 different types of detections are there. But here you can see that there are the more than 5, which is nothing but it's a subcategories. Okay. In next slide, we can look into it. So here we'll be mapping all the like dependent feature into the dictionary. Okay. So here we will be having total 22. Okay. So here like it's like a dictionary, right? So we'll be having a 22 subcategories, but the main detection types will be having the 4 here. Okay. The target feature having total 22 different types of intrusion detection types, which are classified into 4 types. So these are the 4 types. Next, like we will be reading the raw data. Okay. So raw data is having actually 41 columns. Raw data is having 42 columns, but independent is having 41. So there is a one column is missing. So this particular last one, we don't have, this is not included in the like independent columns. So that's why we are creating a column as a target. Okay. We're creating a column as a target. Then we are trying to read the data frame now with the like column names. So these are the steps involved before we are reading the data frame, like reading the independent columns, then read the dependent columns and clean both independent and dependent columns and create a readable data frame. Okay. So now total will be in the target, will be having a different 23 different types of intrusion detection types. Okay. So now here we are trying to read top 5 as well as bottom 5 records to make sure the data frame is loaded correctly. So here again there is one more challenge. Dependent feature is having 22 different types of detection systems, but raw data whenever we are reading like dependent feature it is having 23. So now we have to identify which one is missing. So we have created a dependent feature one as well as data frame features. So we have identified that normal detection type is missing. That's why we have added normal to the dictionary. Okay. Now it's both are matching, dependent feature as well as target detection types are matching. So as it is a multi-class classification problem, it is very difficult to deal with 23 different types of classes. So that's why these 23 classes are related to subcategories. So we have to proceed with the like a main 5 detection types. So that's why we are converting this 23 into the 5. Okay. The 5 different types of detection techniques are normal, U2R, DOS, R2L, and probe. So where we are getting this like 5 is here we'll be having in the dependent feature. So these are mapped with 5 different types. So this dictionary is having a key values, right? So these keys will be having a 23 different types of keys, but values will be having only 5. So that will be covered in the like next upcoming lines. Okay. So here we are trying to read again first 5 and the last 5 rows. Column headings as well as again a summary of statistics, data types. And we are trying to identify how many numerical columns are there, how many categorical columns are there. So we'll be having total 38 numerical columns and categorical columns. If we exclude again like a target feature as attack type, then we'll be having a 3 categorical columns. Okay. And we don't have any missing values here. So we have included like data preparation, duplicate data also we have removed. Earlier, like it is having like a 4 lakh plus records. Once we remove the duplicates, it came up with like a 1,20,000 plus records. Okay. And we have applied like to remove duplicate data, input missing values, and also inconsistencies also we haven't found, but these are the techniques we have applied. Removing duplicate data, first one, then removing missing values. So as we don't have missing values, we no need to apply any additional techniques. Then label encoding. Okay. So it is label encoding. It is having a like a 3 categorical, right? We are converting into different types of labels. So we'll be converting these labels into like a numericals because our model will read only numerical data. We don't have any text data. Then the target is like attack type. Okay, these are the scatter plots against with like a target. So if you scroll down, we'll be having multiple scatter plots. So this is the heat map. By visualizing the heat map, we have come up with like these are the different types of features which will be contributing more. And also like here we have entered into the like feature selection techniques. Before we are doing the feature selection, we are trying to test like variance threshold. Like if is any constant feature, we are trying to eliminate it. Okay, then we have identified like there are the two such features. One is like num underscore outbound CMDS and is host login. Why? Because these features are having same data throughout the columns. So all the records having only one data type. So that's why we are eliminating it. Next, like we are trying to identify top 5 features by using like information again as well as chi-square test. So after applying these techniques, we have identified. So these are the top 5 features from mutual information as well as chi-square test. Then we are trying to implement machine learning techniques. So we have chosen decision tree as well as like random forest. So as it is a multi-class classification, we have proceeding with like a decision tree. Next, we are choosing random forest classifier as it is eliminate the like challenges or disadvantages in the decision tree, as well as random forest is the ensemble model. So always ensemble will outperform the single classifier. That's why we are proceeding with like one single classifier and one like ensemble technique. Okay. So after applying these ensemble techniques, these are the like outputs we have observed. So like we have used the metric like accuracy score, macro, micro weighted. These are related to the F1 score. Then whatever the techniques we have applied, decision tree classifier with like chi-square test, random forest classifier with like mutual information, random forest with like chi-square, and as well as decision tree with mutual information. So after applying this, we have identified that random forest with mutual information feature selection techniques is outperforming compared with the other scenarios. Okay. So here like these are the challenges we have faced while solving this use case. And one more thing is like apart from this one, we have created one of the like Streamlit model prediction app. So for this one, what we have done is like we'll be splitting the data into train and test split. And by using like random forest classifier, we are storing the model as a pickle. Okay. And we are trying to identify what is the maximum and mean value of top 5 features. So these are the top 5 features we have selected from the like mutual information. Then like we have created one more notebook .py file, which is for the Streamlit app. So here we are reading the top 5 features and we are loading the model which we stored in the earlier file. Okay. Then we are trying to identify the predictions. So for this, so we are running this app, Streamlit run IDS underscore app 3y. So here it's like a prediction app. So whenever we are changing these values, top 5 feature values, the prediction also will change. So here we are reading the feature associated its value. And next, like how many number of like classes we have, as it is a multi-class classification problem, and 5 different classes and its associated number index. And what is the prediction based on our selection in the left hand side, and what is the prediction probability also we are getting. So when you are changing this, like the values will automatically reflect here, as well as the prediction also will change in the real time, and also prediction probability also will upload. So here, as we are changing the values, the prediction also changing. Okay. Yeah. Like this app also can be enhanced further, instead of like by using by using the slider, dropping from here to over there, we can upload file, as well as we can able to identify like instead of like single instance, we can able to identify multiple batch of records. Also we can able to identify the prediction as well. So we can take it further and we can enhance it. So as part of this assignment, we would like to mention about this particular app, like whatever use case we have deal, like how we can able to identify the prediction also. And also thank you so much for helping us, my team members, Sunanda, Rakesh, as well as Narayan. Yeah, thank you.